Hi again, everybody. Welcome back once again to our pre-calc course. So this is a quick introduction video for week 3. Hopefully everyone has taken exam 1 by the time they watch this, and you've all done well. Hopefully you remembered. It's all over the place to try to get you to remember, but send me your work. I'm really going to go through your work carefully on exam 1 and make sure that you earned all the extra partial credit that you should have earned. My math lab is not very good at that, so show me your work. Show me your work. Okay, when we get to week 3, first of all, we're going to be talking about sections 2.6 and 2.7 together. So sections 2.6 and 2.7, we are talking about rational functions and their graphs in section 2.6. So a rational function is just a polynomial divided by a polynomial. So that's a kind of rational function that you will see. A rational function is just polynomial divided by polynomial. And then we're going to learn all sorts of things about that, using some arrow notation, finding domains, finding vertical and horizontal asymptotes. We want to make sure we can use transformations like we have already, but transformations to graph rational functions. We want to actually be able to graph rational functions by hand, or at least get a good idea of what they look like. I know we have our scientific calculator these days, but it's a useful skill to be able to understand in your mind, understanding properties of functions to know how to graph them. And then we'll solve a few applied problems involving rational functions. Okay, so that's in 2.6, and then I, of course, got videos going over this stuff. But in 2.7, we're going to talk about polynomial and rational inequalities. So we're going to solve equations. But these equations have inequalities in them. For example, 9x squared minus 6x plus 1 not equal to 0. That would be a quadratic equation. You could use the quadratic formula or try and factor it, but it's less than 0. So how do we go about doing that? So these are polynomial or rational inequalities that I want you to learn how to solve. So that's what we'll do in section 2.7. Okay, so then that's the first set of homework this week would be homework 7. Okay, and I made that due Wednesday night, not Tuesday night, because I know you have the exam, which you can take all the way up until Wednesday night, or all the way up until Tuesday night. So I gave that first homework due date one day later this week. Okay, now, and then we're going to move on to section 3.1. And in section 3.1, we are going to be talking about exponential functions. So these are functions like b to the x. In other words, we have some constant, we call it a base, that's why I'm using the letter b. We have a constant raised to the power x. That's a typical exponential function. We're going to learn everything about those, learn how to graph them. We want to evaluate functions, especially with the base e. Y equals e to the x is something very common function. And so we want to make sure we understand that base e is Euler's constant, which is like 2.7182 something. It's infinite. It's an irrational number, non-repeating decimal. It goes on forever, but we call it e, much like pi. Pi is 3.14159, et cetera, et cetera. So just like we have pi, because it comes up so much in nature that we use a symbol for it, it's the same thing with e. And then at the very end of this, we'll have a little fun looking at some compound interest formulas. You actually get into some financial mathematics. Okay, so that's section 3.1. And then the last, that's tied to section, homework 8, which is due Thursday. And then homework 9, due Saturday, would be from sections 3.2 and 3.3. All right, so sections 3.2 and 3.3. In section 3.2, we're going to talk about logarithmic functions. Now, logarithmic functions are inverse functions to exponential functions. So, for example, if y equals b to the x, then y equals log base b of x is the inverse function for y equals b to the x. Okay, and we'll talk much more about that, but changing from logarithmic to exponential form and back and forth from exponential to logarithmic form. I want you to understand how to evaluate logarithms, use basic properties of logarithms, which are very important in calculus, so you really make sure you pay attention to these. We want to make sure we can graph logarithmic functions, find the domain, and use common and natural logs. Common logarithms are base 10, natural logarithms are base e. So that's section 3.2. And then in section 3.3, we're going to talk about much more in depth the properties of the logarithms. Okay, look at all these different rules we can use to evaluate logarithms, to expand them, to condense them, to do different things. And that will get you through week 3. Any questions, please reach out. Don't hesitate, and I'll be in touch with every single one of you as soon as I've reviewed your first exam. Don't forget, we do have office hours tomorrow from 1 to 3 if you need help. Especially if you haven't taken the exam yet, you need some last minute help, that's a great time. But reach out anytime, and I'll talk to you soon.